Good morning one and all. Today we are discussing about stresses in soil under module 2 lecture class 6 for applied geotechnical engineering 18 CV 62 for 6th semester BE civil engineering students. The content of today's presentation is approximate method to compute sigma z. The approximate method to compute sigma z means stress at any point. If I take this as a ground, if I applying a pressure here to a column, stress below this ground we have to calculate. There are two methods, approximate methods. One is called as a equivalent point load method. Another one is called as a 2:1 method. Coming to the equivalent point load method. In case of equivalent point load method, the entire area, suppose if I consider this as a rectangular area, that entire rectangular area, suppose I want to calculate stress at this point, means we are dividing that entire area, rectangular area, into 4 parts. You can see here part 1, part 2, part 3, part 4. And for this part 1, what is the load we are calculating? For this part 2, the load we are calculating. For this part 3, the load we are calculating. This part 4, the load we are calculating. What is the load from this part at this point? What is the load from this part at this point? What is the load from this part at this point? What is the load from this part at this center point that we are calculating? That is called as a equivalent point load method. Okay. So now I will tell you once again, the entire area is divided into a number of small area units. You can see a small area unit 1, small area unit 2, small area unit 3, small area unit 4, small area unit, and the total distributed load over a number of unit area. The total distributed load over a number of unit area is replaced by a point load of the same magnitude acting at the centroid of the area. So the entire stress we are calculating at the centroid of an area. Okay, let us consider a loaded area having a length L, width B. That O is a point below which P is there. We have to calculate stress. The entire this area, so if I want to calculate stress at this point, means draw a line parallel to the y-axis and parallel to the x-axis. If I consider this as x-axis and this is y-axis. So what? Calculate this area. Once you calculate the area, so the load intensity, total load intensity multiplied by the area will give Q for this particular area unit. Call it as Q1. Similarly, calculate this area A2 multiplied by area unit sigma stress, total sigma stress. If you multiply it, you will get Q2. Similarly, the entire this area A3 multiplied by total stress intensity, if you multiply it, you will get Q3. Similarly, area A4 multiplied by stress intensity, you will get Q4. Next, this area CG point you calculated. From CG point, what is the distance here? By using Pythagoras theorem, you calculate, that will be R1. For this area CG point you calculate. From this point to this point by using Pythagoras theorem, or AC square is equal to AB square plus BC square, or AC is equal to R2, which is equal to root of AB square, so plus BC square, you calculate R2. Similarly R3, similarly R4. Okay. So now in order to do this problem, in order to whatever the thing I told, we are using a basic stress distribution equation proposed by Bosonus. What is that equation, students? Sigma z is equal to Q by z square into 3 by 2 pi divided by 1 plus r by z whole square whole to the power 5 by 2. So this equation can also be written as sigma z is equal to Q by z square into IB by considering Bosonus influence factor, where IB is 3 by 2 pi divided by 1 plus r by z whole square whole to the power 5 by 2. Next, sigma z is equal to, you take out Q inside 1 by z, z at which we are calculating stress will remains constant. Take out 1 over z square outside. Then this equation will be Q1 IB1, because IB is a variable parameter, as R is variable, R1, R2, R3, R4. R by Z is also variable. When R by Z is also variable, obviously your IB value is also variable. So for first area Q1 IB1 plus second area Q2 IB2, third area Q3 IB3, fourth area Q4 IB4, where capital Q1, capital Q2, capital Q3 and Q4 are equivalent point loads. That is the meaning of that heading, equivalent point load method, because it has equivalently load as distributed here according to that area. Therefore equivalent point load. If sigma z is to be calculated at point O, and if that O value is exactly at the center, then your Q1 is equal to Q2 is Q3 is equal to Q4, then you can call that as Q dash. When you call that as Q dash, then your sigma z will be equal to Q dash by z square into IB1 plus IB2 plus IB3 plus IB4. Therefore sigma z is equal to Q dash divided by z square into summation of IB. Next method, 2:1 method. What is meant by 2:1 method? 2:1 method means it is the process of stress distribution from the footing edge. For example, this is your footing edge which is resting on this ground. So how the stress distribution takes place means, from here at a slope of 2:1 this side, from here at a slope of 2:1 this side. What is 2:1? 1 horizontal to 2 vertical, that is the sloping angle at which stress distribution takes place. So how to calculate stress due to application of load? Let me see. Okay, let Q be the load we are applying on a footing of width B. Let us consider stress at point Z. When we say 1 horizontal to 2 vertical ratio stress is distributing, for a depth of Z, for a depth of z, that is, if I equate to 2, the corresponding width will be z by 2, because half of the vertical length will be your horizontal length, so z by 2. So from edge of the footing to this inclined line ends at a distance of z by 2 on left side and also on right side. It not only left and right, this is your footing, means this side also 2 is to 1 ratio, this side also 2 is to 1 ratio, this side also 2 is to 1, this side also 2 is to 1. That means like a trapezoidal way stress distribution takes place. Therefore, we have to use trapezoidal, the line diagram area. That line diagram area means what? So from here to here it is z by 2. From here to here it is equal to width of the footing. From here to here it is z by 2. So total length from here to here is z by 2 plus z by 2 plus b. So 2 is LCM. So it is 2 into z plus z. 2z by 2 plus b. 2 cancels, b plus z. If it is square footing, another side is also b plus z. If it is a rectangular footing, it will be L plus Z. So for square footing, sigma Z is equal to applied load Q divided by B plus Z whole square. For rectangular footing, sigma Z is equal to Q divided by L plus Z into B plus Z. This is the formula which is used to calculate sigma Z at any depth Z by using 2:1 method. Coming to the multiple choice questions, the approximate method of computing sigma Z only by equivalent point load method. Option A is true, option B is false. It is false. Approximate method of computing sigma Z only by 2:1 method. So it is false. Approximate method of computing sigma Z is by both equivalent point load method and 2:1 method. Option A is correct. It is true. When Bosner's equation is given by formula sigma Z is equal to Q by Z square into 3 by 2 pi divided by 1 plus R by Z whole square whole to the power 5 by 2. It is correct. Therefore, it is A. Bosner's equation is given by formula Q by Z square into 2 by 3 pi 1 plus R by Z whole square whole to the power 5 by 2. That is Q by Z square into 3 by 2 pi. It is not 2 by 3 pi. Therefore, it is answer is B. False. Next, Bosner's equation is given by formula Q by Z square 3 by 2 pi 1 plus R by Z whole square whole to the power 5 by 2. So here 3 by 2 pi 1 plus R by Z whole square whole to the power 5 by 2. It is correct. A. Equivalent point load method stress calculation is by formula Q dash by Z cube into summation of IB. It is not Z cube, Z square. Therefore, option is B. False. Equivalent point load method stress calculation is by formula Q dash by Z square into summation of IB. It is correct. A. Stress at any point for a square loaded area 2:1 is given by Q divided by B plus Z into B plus Z. It is A. It is true. Stress at any point for rectangular loaded area 2:1 is given by Q divided by B plus Z plus B plus Z. So plus B plus Z. It is wrong. It is B plus Z into L plus Z. Therefore, answer is B. So the above material is prepared by taking the information from the textbooks as cited above and reference books as indicated in this slide. I take this opportunity to thank Department of Collegiate and Technical Education higher officers for giving me an opportunity to deliver these lectures. I also take this opportunity to thank students for listening my lecture. I request all the Government Engineering College students to please go through the LMS portal, and we have applied MCQ questions. You solve the MCQ questions. If you have any doubt at any point of time, you can feel free to ask in the next class. Okay, so this is about the that is the approximate method of determining the sigma z at any point. So there are two methods. I am repeating. One is equivalent point load method. Another one is, which one? Yes, another one is 2:1 method. Okay, so I hope you understood the concept. Thank you for attending the class.